Today on the Perception and Action podcast, why do many individuals have a distinctive manner of performing a motor action, aka a perceptual motor style? How can we determine whether a particular style is functional? How do styles change with development, sports training, and through rehabilitation? So it's time for a call to action. Hello, and thanks for joining me. This is Rob Gray from Arizona State University. I've been on a now over 25-year journey as a researcher, professor, and high-performance consultant to understand how we acquire and adapt our perceptual motor skills. Welcome to the Perception and Action podcast, where I discuss how psychological research can be applied to improving performance, accelerating skill acquisition, and designing technologies. If you're a coach or an instructor, my goal is to help you bridge the gap between research and application, and to connect your experiential knowledge with skill acquisition and motor learning theory. I want to help take you from using practice design recipes to becoming a master chef who can manipulate the key ingredients to come up with your own innovative training methods. If you're a student or fellow academic working in the skill acquisition field, I hope to keep you up to date on the latest studies and help you get to know the people working in this area. Finally, if you're developing training technologies, I hope to help you incorporate good motor learning principles in your design, pull out key performance metrics from the data, and design effective studies to evaluate your product. To learn more, help support the podcast, and/or work directly with me, please check out perceptionaction.com. Now on to the show. In today's episode, I want to look at a recent article discussing the very interesting concept of perceptual motor style. As I've emphasized on the podcast several times now, specifically in episodes like number 156, where I looked at movement consistency, skilled movements have both invariant and variant components. The variant aspects I've talked a lot about. Those are the things that a performer changes from execution to execution to allow for adaptation to changing constraints. Bernstein's famous repetition without repetition. But that is not to say that movements are completely different on every execution. There are two types of invariants. First, the same action performed by different individuals is going to share some common features. If they didn't, then we wouldn't be able to classify movements into distinct actions like throwing, hitting, catching, etc. The second type of invariance is at the individual level. Even though you don't produce the exact same movement pattern every time, there are going to be some things in common between each of your movement executions. This is what allows us to immediately recognize that's Nadal serving or LeBron James shooting. These unique invariant features you have across executions are what gives us our perceptual motor style. As I mentioned, this interesting topic was recently discussed in an article published by Vidal and LeQuanti in the journal Experimental Brain Research. They begin by first considering the many reasons why even very stereotypical movements can be variable across individuals. This covers some of the things that are hopefully very familiar to listeners. First, redundancy. The fact that the number of degrees of freedom or options that we have for producing a movement are far, far greater than the number of parameters required for a given action. For example, when I reach for my computer mouse, there are 6 degrees of freedom that must be controlled for the action in terms of the position and orientation of my hand. But due to the number of joints and muscles involved, even a simple reaching movement to my mouse has 244 degrees of freedom. On average, there are about 3 degrees of freedom that act on each individual muscle. Thus, there is literally an infinite number of different ways I can move to satisfy the requirements for position and orientation of my hand. As the authors put it, quote, "The high redundancy of the musculoskeletal system, coupled with the morpho-functional diversity of people in terms of their body height, mass, and shape, makes it highly unlikely that any two different persons will adopt the same postural configuration for the same task even under identical circumstances," end quote. The second factor is adaptability. Due to the ever-changing nature of the constraints we face in our environment, we cannot rely on one invariant movement to achieve a goal. Furthermore, our movement solutions are shaped by our training history and any injuries or pathologies we might experience. We also begin with very different individual constraints in terms of our genetics, our developmental stage, etc. If we believe that movement solutions emerge from the pattern of constraints, then we should expect a large degree of individuality because no two people will ever experience the same set of constraints. The final factor is the good nature of variability that I've discussed many times on the podcast now. Trial-to-trial variability within a performer can be highly advantageous because it's related to how much an individual is exploring the perceptual motor space. As documented in several studies by Newell and colleagues, see the video I posted on my YouTube channel titled Searching for an Optimal Movement Solution, individuals vary substantially in the amount of this inherent variability, or the degree to which they explore and look for new solutions versus sticking at a local minimum for performance. The authors next attempt to give a definition of perceptual motor style. Quote, "In the following, we will retain the definition of perceptual motor style as any distinctive and recognizable way in which an action is performed or perception is processed. This perceptual motor style may be typical of a person, group of people, context, task, or age. It may be determined genetically or as a result of development, learning, or pathology." End quote. The variability of performance may be a transient feature of a specific behavior, while style refers to a relatively stable, consolidated feature of behavior associated with a given context and developmental stage. End quote. So a couple important points here. As the authors define it, style can be in terms of the way the information is picked up, the pattern of movement, or both. And we could talk about styles both at an individual level and within groups. For example, genders, cultural groups, or individuals with a particular movement pathology. They also make the interesting point that the word style stems from the word stylus, referring to a writing tool. Over time, it's come to refer to the characteristics of the action of writing, thus style is historically rooted in perceptual motor control. The authors next consider style in terms of information pickup. One of the more well-studied examples of this can be seen in the work using the rod and frame test. This test involves the participants putting their head inside an apparatus containing, surprise, surprise, a rod and a frame. Over several trials, they're asked to adjust the position of the rod so that it appears to be vertical. The main manipulation across trials is the amount of tilt of the frame. Results from using this test allow for classifying people into one of two distinct categories. Participants who aligned the rod so that it leaned to the direction of the tilted frame were defined as field dependent, since they relied on the visual field defined by the frame to judge the vertical. Instead, subjects who were able to align the rod close to the vertical independently of the wireframe orientation were defined as field independent. To judge the vertical, the latter group of subjects relies more on the vestibular and postural cues about the direction or the pull of gravity on the body. Or another way to put it, field-dependent individuals use primarily visual information to orient themselves, while field-independent individuals rely more on the internal senses. On the surface, you can see how this difference might relate to sports performance, and there have been many attempts to relate it. For example, using the rod and frame test for athletes in different sports and at different skill levels. However, in general, no consistent pattern has emerged. But it does seem to be the case that different individuals are attuned to information from their different senses to a different degree. For example, as I discussed in episode 65 when looking at the topic of body awareness, there are very large individual differences in sensitivity to kinesthetic and proprioceptive feedback. In turn, we expect that differences in attunement to lead to individual differences in perceptual motor control. Turning to the motor side of things, the authors first note that, quote, "Different kinds of movement, features specific to an individual, have been described from kinematic or kinetic data. Thus, it has long been known that the idiosyncratic shape or the signature of each person tends to be preserved through wide changes in execution size, speed, and even the effector used. These idiosyncrasies can be picked up perceptually even from limited visual cues. Thus, a common feeling is that we can recognize a familiar person from far away looking at the way the person walks. It's been demonstrated objectively that recognition still occurs with even very impoverished cues, insofar as viewers can recognize themselves and their friends from walking movements or arm movements displayed as time sequences of point lights corresponding to the main body joints." End quote. But it's important to note that even though we seem to be able to easily recognize an individual from their pattern of movement, it does not seem to be because we are picking up simple sources of information. For example, the angle of the person's knees are bent. Stated another way, what is invariant within an individual, their perceptual motor style, is a higher order pattern of coordination, not a simple kinematic feature. In terms of studies investigating the individuality of different patterns of movement, one of the ones that has been most studied is gait. As the authors note, quote, The use of gait for human identification is still very recent as compared to methods based on fingerprints, voice, or face recognition. However, in contrast with the other biometric variables, gait has the advantage of being difficult to imitate or camouflage. Moreover, it can be monitored remotely without the need for cooperation, contact, or high image resolution. On the other hand, gait identification is made difficult by the presence of several confounding factors, such as variations due to walking speed, footwear, terrain, fatigue, injury, or the passage of time." End quote. So key point for me here, there's another way that style can be broken down. First, we can talk about the invariant properties of your movement under a relatively constant set of constraints. So how do you move when you walk across the street? But I also think we have the style in terms of how we adapt to changes in constraints. For example, how do you change your gait when you go over an obstacle? When we look at studies using unchanging constraints, it is relatively easy to identify style and gait. Studies using motion tracking and force plates have shown that individuals can be classified with an accuracy of 99%, even when the measurements are taken 2 years apart. One variable that seems to be effective for this purpose is the phase relationship between the leg and foot. This seems to be related to the energy expenditure, with different individuals optimizing using different phase relationships. Another type of movement the authors discussed in this section is one I've also covered many times on the podcast: eye movements or gaze behavior. Similar to the work on gait, it's possible to identify individuals based on their patterns of smooth pursuit when tracking a moving object. The final type of movements discussed are arm movements, or in particular throwing. For this, the authors refer to a very interesting study by Maselli and colleagues published in 2019. In this paper, the authors begin by noting that throwing for distance and accuracy is a uniquely human skill that's been argued to be supported by an inherited motor plan in which different phases, for example, using just your arm versus your whole body, develop at different times. But despite this, the authors note that when asked to throw and hit a distant target, adults who have not been trained in throwing relevant sports display a heterogeneous spectrum of throwing strategies. The goal of the study was to try and capture some of this individuality or style in throwing. To this end, whole body kinematics were recorded from a sample of 20 untrained participants, 10 male and 10 female, during unconstrained throwing to a target 6 meters or 20 feet away. There were 2 recording sessions, with all 20 participants recorded in the first one and 6 returning almost 2 years later for a second session. A principal components analysis was used to characterize the different throwing strategies, and machine learning techniques were used to attempt to recognize gender from the throwing data. What was found? Lots of evidence of different styles of throwing in terms of the gross movement patterns, stepping action, and arm trajectories. For example, 4 distinct stepping strategies, no step, step with the left foot, step with the right, and a double step were found. Overall, a model with 5 principal components could account for 75% of the variation in the data, which included a total of 2,000 throws. It was also found that there were individual differences in terms of how consistent each thrower was from execution to execution. While some were more stable across throws, others showed larger intertrial variation in arm kinematics. Returning to the topic of how throwing develops, it's been proposed that this skill develops in 4 distinct stages from the ages of 2 to 6. Beginning with a stationary base of support, it evolves into a weight-shifting stepping mode. The first 2 stages involve the stationary base and the arm moving in a particular anterior sagittal plane. As trunk rotation is added, the arm trajectory moves in a more lateral horizontal plane. Finally, different stepping patterns emerge. Interestingly, the authors propose that the large gender differences found in throwing, which could be accurately identified by the machine learning in the study, may be due to acquisition of throwing stopping at different particular stages. Quote, "Generally, during development, preparatory movements are progressively introduced in the throwing behavior that tends to eventually converge towards a profile that optimizes forceful throws and indeed is evidenced in fastball sport athletes. However, not all individuals achieve this final stage because skill acquisition can stop progressing. A clear gender gap in proficiency is retained throughout development, and girls are more prone to stabilize at an intermediate stage of throwing proficiency." End quote. For me, this can be understood in terms of the differences in constraints. The different sports like baseball, football, and cricket that males are more likely to participate in have higher spatial temporal constraints for overhand throwing, which encourage the emergence of different movement solutions. The authors also make an interesting point about stability of movement solutions used. Quote, "The finding that most participants were stable in their throwing strategy suggests that in adulthood does not involve the recruitment of exploratory strategies. Results from the second session confirm this conclusion. All the retested participants exhibited a stable throwing behavior during the first session, retaining their style after 2 years. The throwers who were instead unstable showed a more exploratory behavior in the first session, tending to stabilize with time into one of the preferred solutions previously adopted." End quote. Again, it seems as if a major part of the style and individual difference is in terms of the relative balance between stability and exploration in the movement solution. Returning to the main article by Vidal and Laquanti, the authors give a few reasons why characterizing and monitoring these perceptual motor styles we have looked at could be important. First, quote, "Differences in perceptual motor styles, since they are idiosyncratic, can be more or less efficient, raising the question of when they need to be adjusted to maintain optimal control." End quote. I would agree with this, with the caveat that we need to be very careful to take into account an individual's constraints and intrinsic dynamics when evaluating the perceptual motor style. As I discussed in episode 20E and the video on my YouTube channel called Towards Individual Optimization of Movement Coordination, something that looks ineffective on the surface may be optimal for that particular individual. The second main reason that our authors give for the importance of this is that a change in perceptual motor style could be indicative of the beginning of a pathology or injury. Finally, the authors consider in more detail how we develop perceptual motor styles as we learn. The main mechanism they consider is the weighting of different sensory information. For example, weighting proprioceptive information more heavily than vision with practice. I would suggest instead of this weighting idea, the same concept can be captured by education of attention in the direct learning approach. To conclude today's episode using the author's words, as this review has attempted to broadly summarize, the perceptual motor style may vary from one individual to another, from one task to another, from one pathology to another, as sensory motor transformations show considerable adaptability and plasticity. While the behavioral evidence for individual styles is already quite significant, much work remains to be done to understand the neural and mechanical substrates of the inter-individual differences in sensory motor performance. End quote. Okay, that's it for today's episode. Remember, you can contact me at robgray@asu.edu or follow me on Twitter at ShakyWeights. To find out more about the podcast, please check out perceptionaction.com. Finally, to support the podcast and receive bonus materials, including written transcripts, please head over to patreon.com/perceptionaction. This is Rob Gray from ASU. Cheers for now, and keep 'em coupled.
Now hear the winter will cut you quick.